Sine, negative sine becomes what? Negative cosine? But then I do have to apply a chain rule. So I get negative pi cosine pi of x times chain rule times another pi. What's pi times pi?
Pi squared.
Now plug in 1 and get your answer.
1 over pi squared.
Yep, because I get a 1 here. The top's a negative 1, huh? And then the bottom go whereas you get your negative pi squared. Everyone, what's the cosine of a pi? So all that math in there, I heard it, 1 over, because a negative over times a negative would make it what?
Negative.
Negative 1 over
Pi squared.
pi squared. Because go whereas there's 3 negatives, true? Cosine of pi is negative 1. Oh, that was a good one, wasn't it?
Mm-hmm.
All right, cool. I liked it because it's the chain rule thing. I want to make sure everyone's recognizing chain rule. I also like when you recognize I don't need product rule here. I don't need product rule. That's a pi. And the other thing, you get a 1 over x. You say, well, I don't need quotient rule. I was the student, everyone, back in the day. I would do quotient rule on that. I would be sitting there doing low d high minus high d low. I didn't think to say, that's just x to negative 1. Do power rule. Cool. All right, let's try another one. I like this. Number 25. Super job with that one. Take a minute. Take 2 minutes. Take your time on that one.
So it's 1 over 0 form. 1 0 is 1, right? No, it's a 0 over 0.
Good. All right, very good. Does that have an L in it? Well, 35 did.
We get 25, right?
Yeah.
Half the answer.
Oh, yeah. All right, first of all, I'm going to substitute 0. U 0 is 1. 1 minus 1 minus 0. 0 squared. I can do what?
About half of the motion.
Yep, L'Hopital's rule. All right, what's your VX?
B2x. Minus 1.
Good. Amber, do you see that becomes what?
0.
0.
Good. Minus 1. 2x. Now plug in your 0.
0 over 0.
Oh my goodness. What does that mean? Don't stop. We get 0, 0 again. Do what?
Do it again.
Do another round of Lopi. Lopi round 2. What's your VDX?
Q over x.
What's your all that junk?
0.
What's your 2x?
2.
Is this the answer?
No, half.
I've had some students tell me the answer is infinity here on a test. You what? I think they thought that was infinity. That's not infinity, that's a what?
0.
What's e to the 0?
1.
I'll go with that. Yeah. And the other thing is, the only thing I didn't like about 25 is this. I'll do an L1. I'll do an LN1. Is I wish I had something like this. Or e to the 5x or something. You know? Because I want to make sure everyone's aware of what rule. So would you try that? So this is 25 extended. E to the 5x minus 1 minus that, all right, plug in 0, what do you get? What's e to a 5 times 0?
0. No, e to the 5 times 0.
E to the 5 times 0, e to the 0 is still up.
1.
Right, anything 0 power 1. 1 minus 1 minus 0.
0.
0.
Okay. Well, it's like the last one. Yeah, but that's what I wanted number 25 to have, because I want to see everyone tell me the derivative of e to the 5x. Oh, the derivative of e to the 5x. I'm grading tests I run, and this is what I'll get. The
No.
derivative of e to the 5x is e to the 5x. No. 5 e to the 5x. Change rule. I love it. And what's this?
It'd be,
1.
That's-
it'd still be 0 over 0.
Now, I want to know the answer to this question.
It's not easy.
Oh boy, it's gonna be a little different now. Because I'm gonna substitute your 0. What's 5 times e to the 0?
5,
5. E to the 0 is 1, right? 5 minus 1 is,
4,
4.
now, plug in 0 here.
0.
What's that mean?
Does not exist.
Yep. Did everyone see that? Cool. I know it's a goofy answer, I just wanna make sure everyone's aware of what? E to a 5x or cosine of pi x, these things, right? Chain rule, chain rule, chain rule, chain rule, right? It just keeps coming up a lot. Alright, we need one with an ln. Alright? I know, I'll do one of these with an ln. That sound good? You want a natural log? Well, I can't use 0 because natural log is 0 to 5. How about 1? Sine of pi times, no, that's not 0. How about that? Actually, that wouldn't work either. Why should you give 2? Everyone, one of these, L'Hopital's rule doesn't apply. Which one is it? I'm racing. I was like, wait, I'm gonna put that back up there. Which one of these is L'Hopital's rule not applying? See, I put in 1, natural log of 1 is 0. You can check it on your calculator. Sine of pi times 1 is 0 as well. So in this scenario here, I get L'Hopital's rule, right? Over here, natural log is
1.
0. Natural log of 1 is 0.
So the limit's 0.
But here, what's the
Negative.
cosine of pi?
Negative.
1.
There's no Lopi here. You don't do Lopi. I didn't want you to think you always assume it's a Lopi. And what's 0 over negative 1?
0.
That number's 0. Do you see? Let's work that one out. What we gotta do? Indeterminate form. H. Alright. Well, this one's easy, huh? And then I step away and you correct my error.
Pi.
Right? I step away, you correct my error. What's missing? Oh, I love it. Oh, so, let's see. Final exam. Multiple choice. Is it A? Is it B? Is it C? Is it D? Is it 1? Is it negative 1? Is it 0? Is it 1 over pi? Or is it E? Does not exist. Sorry. That'll work.
D.
See, sometimes people miss the negative. Cosine of pi is what?
Negative 1.
Does everyone agree it's D? What do you think? D? You plug in a 1 here, you get what? 1. That pi stays. Cosine of pi, you can check it on your calculator, you can be in radio mode, right? We all know, you always want, do you notice these cosine of pi's and these sine of pi's come up like in every problem? So sometimes when I'm grading, I see this written right near the student's name all the time. It's the old what? Unit circle? Charlie Sheen, Charlie Sheen, Charlie Sheen, Charlie Sheen. Pi over 2, pi, 3 pi over 2. And students use this a lot because they come up so often. So what's the cosine of pi right there? What is it? -1. But the answer is -1 of pi, right? Cool. For the test, do I make that free response?
How'd you get that?
Oh, do grades this? Look, cosine of pi will be this what? -1, but in front of it's a what?
Pi.
A pi, you got a 1 over 1 divided by pi times a -1.
Oh.
Yep, Amber sees it. Good. Cool. Great job and stuff. Any questions on Loki? All right. Hey, so for the rest of class, very cool section. Before we do 4-7, we'll do 4-7 today. There are 2 sections, 4, 5, and 4, 6. But it's everything you applied in 4-1 to 4-3. So this comes into play. And they go, what are the titles? Summary of curve sketching. And they want you to apply the ideas of concavity, max and mins, combined with everything you know from pre-calc, where you can find asymptotes. How do you find vertical asymptotes? It's where the denominator, right, is non-existent. The x value is in the denominator where it's non-existent. And make some sketches. All right, well, everyone, I don't think you'll have any trouble with them. To me, they're just more practice problems from what? 4-1 to 4-3. They want you to practice getting the first derivative and the second derivative to check what? Concave up and concave down. But, one of the problems is even, okay? And so the even answers, you heard Art and I discussing, he wanted to check number 32. I assign even ones when it's I'm like, that's a really good problem. I know the answer's not in the back of the book, so I want you to check me the answer. So in 4.5, the one even problem I assign for practice is number 14. Well, I won't do 14, but can I do one like it? Sound good? All right. It's like 14. There you go. Now what's my question? Find the points of inflection. About. This is y, this is f of x. Find the points of inflection of y equal to x squared over x squared plus 16. What derivative do we have to get to?
Double, second.
Second. Everyone agree? We'll go through first derivative. We could look at the max and mins if we wanted to, but we're really getting to what? Second derivative. Okay? Well, it's an even problem. Students will get it. They can check with me. Yeah, but I know what happens with this problem. Everyone gets the first derivative. Watch. No problem. And then the second derivative, it starts what? So it starts getting really big and bulky. Okay, so that's what we're going to be careful with, all right? So we're going to take it very slow on the what? Second derivative. We're going to be careful with our factoring. Sound good? All right, let's do y prime. You'll blast through this. Ellen, rock it out. Quotient rule. Here, you're m, you're n. Low. What's d high?
2x.
Minus high. What's d low? All over. Low. You never expand the denominator, do you? Never do it. Never do it. In this low d high minus high d low. Never do it. Just leave it like that, right? Now, I knew you all can distribute and finish that top. What's that times that? What's that times that? 2x cubed plus 32x minus,
2xp.
oh, beautiful. This cleans up nicely. What cancels out?
2x cubed.
Bye-bye. I'm happy because this is a nice clean 32x, everyone. Yeah. It's for sure. So far, so good. Yeah. Points of inflection, that's where the second derivative is equal to 0 and the second derivative changes sign. So I now have to go to what?
Second derivative.
Alright, we're gonna take this slow, huh? Here we go. This can build on us real quick, we're not gonna let it happen. Second derivative. By the way, everyone, if you've ever noticed, don't let notation bug you. That's dy dx. Sometimes they write this like this. I've already had some students ask me about this from the textbook. They go, what the heck does that mean? It says second derivative. Does anybody want to know why they write it like this? If dy dx is that, this is derivative of this? Because what they're saying is, check this out. They're saying, take the derivative with respect to x
And then y.
of this. Right? And you get dd making it what?
D squared.
D squared y, and then you got how many of these? That make sense? So, but anyways, you and I get to choose our symbols here. Can we just write y double prime? Alright. Alright. Here's your new M and N. Unless you want one of those letters. Nah, we'll still use M and N. Just look here, okay? Alright, low.
Professor,
Oh, sure.
instead of that, why don't you do 32x times x squared plus 16 to the power minus 2?
Brilliant. Everyone, Art wants to do this with product rule, and you definitely could. He was saying he would bring this up to